All right, the Lewis structure for the thiocyanate ion. All right, carbon has 4 valence electrons, nitrogen has 5, sulfur has 6, and then an extra electron to make that 1 negative. Let's add them up and you get 16 valence electrons. All right, carbon is the least electronegative. We're going to put that in the center, surround that with the nitrogen and sulfur. All right, we're going to need a bonding pair between each atom and the central atom, and that's going to use up 4 of our electrons, so we're down to 12. Okay, next we'll give the terminal atoms an octet. All right, so 6 on the sulfur. Oops. There you go. It's 6. All right, we're down to 6, and then let's get nitrogen 6. And that's going to use up all our electrons. All right, got 0. Sulfur is it's got the octet, and so does nitrogen. However, carbon does not. So we need to move some of these lone pairs over to the central atom. Let's do this here. Move that lone pair over there. Move that lone pair over there, and we're going to get a structure like this. And you'll see that Lewis structure here in gray is going to satisfy the octet for all 3 atoms. However, if we go back to let's say the step here before we move those lone pairs over, you'll see that there's a couple different ways we could have done this. For example, we could have moved 2 lone pairs from sulfur to make a triple bond between carbon and sulfur, and that would lead to a structure that also achieves the octet for all 3 atoms in that Lewis structure. So that's another possibility. Okay, and if you just flip that and do the same thing on the nitrogen side with having the triple bond, you get the same thing with just flipped with a Lewis structure that looks like that. All right, so all 3 Lewis structures have achieved the octet for all 3 atoms in each of those structures. Now, only one of this is going to be valid, so we're going to need to take a look at their formal charges. All right, the formal charge, let's do this in let's see here. All right, so the formal charge, simply you can use the valence electrons of the atom in the molecule, minus the dots, which are the electrons, minus the dashes, which are the bonding pairs. All right, and you want to get the Lewis structure with the lowest formal charge. That'll be the most stable, most likely scenario. All right, so for this nitrogen there, you do 5 valence electrons. Nitrogen has 5 valence electrons minus the 4 dots. Right, that's going to give you 1. Minus the 2 dashes, that's going to give you -1. So the formal charge on the nitrogen right here is going to be -1. Right, the formal charge in the carbon right here is going to be 4 valence electrons minus the 4 dashes, and that's going to be 0. The formal charge on the sulfur has 6 valence electrons minus the 4 dots. 6 minus 4 is 2, minus the 2 dashes, that's going to be 0. All right, so formal charge is 0. Okay, over to the structure here in blue. Nitrogen has 5 valence electrons, minus the 6 dots, that's -1, minus another dash, that's -2. So already this is not going to be the correct answer. All right, over here to our last one in red. Nitrogen has 5 valence electrons. Minus 2 dots and 3 dashes is a 0 formal charge. Right, carbon is going to have 0. 4 minus 4 dashes. And sulfur here has 6 valence electrons. Minus the 6 dots is 0. Minus the dash is -1. So this one has a -1 formal charge. So you're down to 2 structures here, and they both have this. They both have a formal charge of -1. So now we have to take a look at which criteria based off of electronegativity, and pull that up here. So electronegativity, you can see that nitrogen has a greater electronegativity or desire for those shared electrons. So it would make sense to put that -1 formal charge on the nitrogen side. So this would be the best Lewis structure for thiocyanate.